right, we'll see. If we have a chance, we can discuss more. But now let's move on to a second topic. So an urban ecosystem, just very superficially, is an ecosystem that is urban, right? But the problem is, what makes an area urban? Human.
Human activity.
Human activity. Can we get a little bit more precise? Human presence, but we need to have human activity and a lot of buildings. So activities, not just in terms of doing things, but we are building things, right? So there need to be lots of infrastructure. So what makes an ecosystem urban? Technology, which is part of human activity. Right? Okay, good. Anything else that you will kind of relate to urban? So any ecosystem that has a lot of people, those people who are doing a lot of things, are using technology and are building infrastructure, then we'll probably call those ecosystem urban ecosystem. Agree? Okay? Anything?
Very high.
Human density need to be very high.
Yeah.
Okay? So not just a lot of people, but they live in a very small area,
Yeah.
crowded, lots of them. All right?
Yeah.
Cool. Now, a little bit quiz. Is this urban? Is this an urban ecosystem? What do you see on here in this picture that make you think it's an urban ecosystem based on what you guys just said? What did you see here? Infrastructure, yes. You see lots of building. Industrial activities in the background, right? Trees. Because you see trees, you think it's urban. All right. What? Park. Park is not just any woodlands, right? Parks are different from a forest in terms of how is a park? Well, they are all trees. A forest has lots of trees. Park has trees too. But you can immediately recognize park. You won't call that a forest. Why? Artificial. How do you know it's artificial? In terms of image, how do you recognize something is artificial? Huh? What?
The diversity is really.
Diversity is lower. For example, maybe the same type of trees.
Yeah, and have like certain pattern, not like the natural.
What kind of pattern? You mean geometric pattern, right?
Yeah, geometric.
Right. Such as?
The trees are all planted tidily.
Or maybe more in a very ordered way, right?
Yeah, older way.
Mm-hmm. So the spaces between them are equal, things like that.
I think.
Okay. So immediately you can recognize that's a park. That's not a natural forest. Is this urban? Well, this is actually an area you guys are familiar with, Taoyuan. I took this photo from an airplane, so looking down, right? So there are lots of farmlands. There are some ponds, some waters, yes, and some villages, houses. Okay, do you call this an urban ecosystem? No. What would you call it then?
Rural.
Rural?
Yeah.
Agriculture? Do you call it a wetland ecosystem?
No.
No, yes. Suburbs?
Suburb or rural, yeah.
So what's the difference between this and this?
The density of it.
Density, because earlier you mentioned density, right? So they need to be like living very close together. So when you have houses that are really far apart, for you, it's probably not quite an urban ecosystem. So density matters. Agree? Okay. How about this one? Okay, I know some of you are familiar with this reclaimed land. 填海造陆嘛, reclaimed land that was turned into an industrial park. Is this an urban ecosystem? I mean, it's very dense. There are people, lots of infrastructure. And look at the waterways. It's all cut out, like straight, it's patterned. It's very artificial. It's not like natural river and coastal line, right? So do you call it an urban ecosystem? Why not? Because industrial park is not an urban ecosystem. Then what kind of ecosystem it is? Every piece of land, every Earth's surface belongs to some sort of ecosystem, right? So what would you call it then, if it's not an urban? Do you call it a coastal ecosystem? Why not? It's coastal. Just too many people, too much, lots of infrastructure. I just cannot call it a coastal ecosystem. All right, so something to think about. Why am I using these pictures to challenge your idea about urban ecosystem? It is because it turns out we don't actually have a standard, well-accepted definition of an urban ecosystem, urban area or urban population. What we have now is each country has its own definition. So when I'm trying to quantify, like for example, global urbanization, I just adopt the definition from each country. Now, as a scientist, you'll probably immediately sense there's something wrong with this practice. Now, let's take a look. So when you see a statement like this, well, it's issued by United Nations. So a bunch of scientists are behind this number. They estimated by 2050, 2/3 of the world's population will be living in urban area. But then wait, we just say each country define urban area differently. So what does that number mean? Well, in next slide, we'll see some countries' definition. But very quickly, I just want to point out that because the definition of urban area is somewhat subjective, even like political or like regional, depending on the country. So when you are looking at those global estimates, you need to know that they are simply a sum of all the data that are based on incompatible, inconsistent definition. So be careful about those numbers. It's very rough. And it can change depending on how you define urban area. So now let's take a look at some of the countries. For example, Sweden. They defined urban area as built-up area with 200 people, 200 inhabitants. Well, I mean greater than 200 or more. And also, you need to have houses that are at most 200 meters apart, so within 200 meters apart. So that's the density we're talking about. But they use houses as the criterion. So houses need to be less than 200 meters apart. If you satisfy those two criteria, you can call this area urban area. Now how about Japan? 50,000 inhabitants. Look, in Sweden, when you have 200 people living together, wow, that's an urban area. Well, in Japan, it's just like rural area, right? It's like, you can call it a village. You don't really call it a city or a town because you need to have at least 50,000 people or more. And also, you need to have 60% or more of the houses that are in the main built-up area, meaning lots of pavements, blocks of neighborhood. Most of the people 60% of the people 6% of the houses, need to be located in those main built-up areas. And you also have, 60% or more of the people that are engaging in non-agricultural jobs. They need to be factory workers, they need to be business people, they need to be engaged in professions that are not agricultural. Industrial, public service, things like that, bank. So this is very strict, right? Now let's take a look at let me see which one is more extreme. India is similar to Japan, except that their minimum number of population size is smaller. Let's look at Singapore. The entire country is an urban ecosystem. Well, it's true, right? It's a city nation. So they just simply defined our entire population, our urban population. We don't have rural people. So this is a map. As of 2018, the minimum number of inhabitants for you to call an area urban across the world. So look at this color. Those are the countries that require more inhabitants in order for them to call an area urban. And these are the countries, like Sweden, right here. Those are the countries that you can have an urban area with just a few hundred people. That's good enough for them. So do you see a pattern? What kind of countries tend to use higher threshold of minimum population size to define urban area? What kind of countries? China, Japan, right? And what kind of country will use lower numbers? This is Iceland, Denmark, Sweden. So it probably has something to do with the entire nation's population size and their livable areas. If all the lands in that country are livable, they probably are not going to be too about density. But for Japan, there are only very limited lowland area that is hospitable for people. So they are very sensitive about, like, you need to have certain aggregation of people in order for you to call it an urban area. So you can immediately tell, like, there are some differences between countries depending on their current condition, the entire nation's condition. So urban area, the definition is relative to the country's overall condition. Not globally, but only relative to the country's own condition. How about Taiwan? Okay, we are all Taiwanese, right? Are you a part of urban population? Yes? No? So do you guys know what makes an area urban in Taiwan? Guess. Give me a minimum population size. What do you think in Taiwan to qualify an area as urban area? You need to have how many people? 10,000? 10,000 sounds right. How about density? There you go. According to Executive Yuan in Taiwan, 行政院, okay. In Taiwan, a settlement with a population size of more than 20,000, so you're close. You're close. With more than 20,000 people, and we also require a population density of over 300 people per square kilometers in order for you to call an area urban. So this is the density map, human population density map of Taiwan. And the more like red, orange color, those are the areas with higher population density, especially anything you see in red. That's probably qualified for urban area. And the green, yellowish areas are the areas with lower population density. So we can tell that from this map, majority of the urban areas in Taiwan are in lowland, western part of the island, which we all know because we are familiar with our island, right? Okay? So Taiwan is kind of, our definition is kind of in the middle comparing to all the countries in the world. Not as high as Japan, but much higher than Sweden. Do you guys know the minimum population size to qualify as an urban area in China? How would you guess? Japan is 50,000. We are 20,000. How about China?
100,000.
Yes.
Wow.
You are correct. Exactly, 100,000. So you will see how much, what's the level of the average population size in that country matters a lot. So when you have lots of people, you will up your minimum threshold. Otherwise, your entire country will be urban, right? So you can't, if it's 200 people, then the entire China are urban areas. So they need to go up because their population size is large. The country has a large population size. So what do you see in common? Like we actually look at the tables, right? What do you see in common in the definition of an urban area across countries? From just the couple ones we talk about, Japan, Taiwan, China, Sweden. What are certain things in common? They all use population size, some sort of minimum population size as a threshold, and some use densities, either human density or the density of houses. Because the distances between houses is another way of defining the density of the houses per square kilometers, right? Similar. So those are probably the two most important, commonly used criteria across countries. And a few countries you notice, like Japan and India, they use occupation, but we don't use occupation. So that's what people do, human activities. Right? You mentioned earlier. Okay. So based on those exercises and going through different countries, a sample of different countries' definitions, we know there are a couple key points for us to identify an area as urban. We probably care about some sort of minimum population size, and we care about how crowded they are or their houses are. So some sort of density measurement. And that relates to physical features, such as the distance between houses. So houses are built up areas. And earlier you guys also mentioned they are straight line, they are patterned park. You know, it's more artificial geometric features. Those are the physical features. And also human economic activities. They are all businessmen, they don't do like agriculture, they are not farmers. They don't raise livestock, things like that. So we will use all those four, but those two are the most widely accepted criteria for defining urban ecosystems. So all fours are saying one thing. All four are saying human influences. So urban ecosystem, immediately, we can probably, with just one sentence, to define it as highly altered. Highly altered, I guess you can add natural ecosystems with intense human influences. And there are some characteristics about urban ecosystems because it's under intense human influence. The number one is we can probably expect a lot of novel niches. Remember we talked about niches? All the biotic, abiotic conditions that allow species to survive, or the functional role that a species play in the community, in the ecosystem. Urban ecosystems tend to have a lot of novel, non-natural niches because of human activities. We create a lot of niches. Can somebody give me an example? You guys are urban population. You are familiar with urban ecosystem. Human created novel niches for other species. Examples? Right. We have underground sewage systems, provide niches for rodents, rats, bats, also for bats, right? Some bats.
Cave-living bats.
Right. So our sewage system actually expanded their distribution into urban area because we provided niches that they are pre-adapted to, right? Another example, anything?
Feeding.
Right, so niche, novel niche for pigeon is? So they have more places to rest to nest, right?
他们会在那边筑巢。
Right. Their nesting site attached to human buildings. A little platform we created. Yes. Okay, cool. So next lecture, we will cover some of this in depth about evolution in urban ecosystems. But for now, let's move on to the second characteristics. Urban ecosystems tend to have a lot of sharp boundaries and straight-lined features. So like the water channel, right? The river channel, because it's more convenient for us. So we tend to change, even for a park with trees, we tend to arrange the trees in a way that we have very sharp boundaries between park and nearby buildings. Even within the park, between different trees, or trees and pond, all those features, you will see very sharp boundaries. The third characteristics, this we will go a little bit further in some details and examples in next lectures, is that urban ecosystems rely heavily on subsidies of energy and materials from outside urban ecosystem, such as the food you eat every day. Well, you're going to have lunch, right? So, well, if you can ask the restaurant, well, if you go to 7-Eleven, okay, you can see where the food was produced. Just look at the package. It will say it's produced in Tainan or something, right? Go take a look. It's definitely not produced in Taipei. So it's being transported or imported from other ecosystems into this particular urban ecosystems for you to survive. So because of lots of human in urban ecosystems, and they don't do agriculture, remember? A lot of urban ecosystems don't do agricultural activities. So they relied on food, energies outside urban ecosystems. In another way, it's not self-sustaining. It has a strong connection with ecosystems outside itself. Now, from a scientist's point of view, those are just the generic characteristic of urban ecosystem. But we are scientists, so from our point of view, urban ecosystems are also experimental ecosystem, because if you think about it, these urban areas are repeatedly manipulated by us. We are manipulating the original natural ecosystems into urban ecosystem, right? And we are doing it all across the world. So urban ecosystems actually occur in all climatic and biogeographic regions with different biodiversity background. And this with different kind of like natural selection gradient. Different elevation, different climates, humid climate, dry climate. We all have cities in different climatic and geographic regions. So that provide a laboratory for people to study urban ecosystem, particularly social ecological systems that are unique to urban areas. So it's exciting in a way from a scientist's perspective. Well, I know you guys probably don't like urbanization, but you can view it as a laboratory and ask questions, hypotheses about it. And you got all these samples you can use. Big cities, little cities, city in the north, city in the south, coastal city, inland cities. Those are all your study materials. Now, I know some of you are evolutionary biologists, so let's take a look at urbanization through time on Earth. This is a long view history of urban ecosystem evolution. How long? Since Holocene, 10,000 years ago. That's it. Look. 10,000 BC, all the way to modern time, and even we can project a little bit into the future. So the red areas are the proportion of human population, global human population living in urban area. The blue areas are the proportion of people living in rural areas. So you can see urbanization occurred in recent time. In the past, people live in tribes and small villages, even like just in family groups. They don't really congregate together. But in recent time, we start to congregate, and the situation has become more and more serious, right? More and more people are congregating in larger and larger urban areas. So proportionally speaking, you can see it's taking over in recent time. Now I have some numbers. So earlier we saw this, United Nations actually did projections. By 2050s, the global population is projected to be close to 10 billion people. That's the entire global population. And they are also projecting 7 billion of those 10 billion will be living in urban areas. So that's a high percentage. Now, of course, global urbanization is more of a recent phenomenon. So we're going to take a closer look at modern time. There will be a couple of statistics that we will look at together. The first one is how many people or proportion of human are living in urban area in recent decades. The second one is in terms of land mass, how much land, or the proportion of lands that are being converted to urban areas in recent decades. From 1960 to 2021, so these are the recent time. Currently, 2021, we have about 4 billion people on Earth. Half of them living in urban area, this pink line. It's increasing over time in recent decades. On the contrary, the proportion of people living in rural areas are decreasing. And you guys were born when? 2000, 2001? So you guys witnessed the crossover of our world from more people living in rural area to more people living in urban area. So you all witnessed this crossover. You don't look happy. You don't like to see the crossover. In 1960, this is 1960, right? This is the world map. The color indicates the proportion of population living in rural, urban area. So green color indicates a higher proportion of people living in urban area. And the brownish color indicates lower proportion of the population living in rural, urban area. So in the 1960s, surprisingly, United States, Europe, they don't actually have that much people living in urban area. But Australia, actually, among all the countries, had the highest proportion of people living in urban area. Why? From what you know about Australia's natural environment. Yes, because they have too much inhospitable environments for human anyway, deserts, dry area, extremely dry areas. So their population are very concentrated along the coastal area, small coastal towns, from very early on. So they actually had the highest urbanization of all countries very early on. By 2021, look, a lot of countries are catching up, particularly almost the entire America, North America and South America. They are all in the green now. Australia stayed green, and then Japan caught up. South Korea caught up. Also some of the African countries and China. By 2050, in the future, well, actually when you are my age, in your lifetime, you'll see this. The whole world is becoming green, right? except a few countries in Africa and Middle East. And I think most of the countries are getting darker color, darker green, so it's more concentrated. People are even more concentrated to urban area. Earlier, remember, we mentioned like by 2050, 2/3, 68% of the global population will be living in urban area. But look at Taiwan. By 2050, we're being projected to have almost 90% of the people. 9 out of 10 people will be living in urban area when you are my age. So there is a rapid increase in urban population, no doubt. And we're looking at even higher degree of urbanization in the future. The second question about the land that are being converted to urban area. With this rapid increase in urban population, do you expect an increase in urban area? More global lands are being converted to build-up area or not? Yes? Not necessarily. Depends. Can you show your hand if you think it's going to increase as more people live in urban area? We are going to convert more land to urban area, to build-up area. And is it going to be a linear increase? Or it's not going to increase as much as human population? Is it going to be a one-to-one relationship, or it's not going to increase as fast as human population, urban population? Most of you think it's going to increase, right? But now I'm asking how fast or how much is going to increase. Let's look at some numbers. Of course, those are modeling results, okay? So it's based on the data in the past, but then the scientists also projecting to the future, 2100, right, the end of this century. So those are different scenarios. The different colors represent different social, economic pathways. So red color indicates business as usual, which we typically call it fossil fuel developments, meaning human development still relying on fossil fuel. So those are like probably the worst type of scenarios. And then there are some other colors, such as the blue one, SSP1. This is the sustainable development, meaning that they are assuming that people will become more conscientious about the environment as they develop their economics, as they expand their urban areas. They will pay more attention to sustainability and being environmental friendly. So those are different scenarios of human behavior. But no matter which scenarios, the urban land area are going to increase. It's just a matter of how much, how fast. So the bad news is it's going to increase, like most of you thought. But the good news is we can decide how fast and how much land will be converted to urban land through our actions, our behaviors. This study, in addition to the global prediction, they also use a couple specific regions as a case study, as examples. So these are the northeastern United States, Boston, New York, Philadelphia, Baltimore, Washington, D.C. Those are the northeast area of United States. And these are the scenarios that are like sustainability, so it's like slower development or more conscientious development. This is the middle scenario, and this is the worst scenario. 2030, 2060, 2100, different immediate future, further down the road, and the end of this centuries. The dark blue colors are the urban areas. So you can see that if we are not changing the way we are developing our economics, the urban area is going to expand much faster and cover much larger areas. But if we can go this route, we can keep it low. By having more people living in smaller area, right? If we do it smart, we don't have to expand the land area. We can still have increased urban population without increased urban land. So it's a possibility. It just depends on how we design the city, how we design urban ecosystem. Can we make it smart? You don't want to sacrifice people's comfort or convenience, but there must be ways to do it so you don't have to expand urban lands. So I think that's a take-home message from studies like this. This is an image. This is a photo taken by an astronaut, a United States astronaut, from the space station, International Space Station. Do you recognize this? What is this? He took a photo of New York? Taipei? Taipei? New York? Danshui River, yes. So this guy, I think his name is Thomas. Anyway, Tom took this photo of Taipei on July 26, 2021. Where were you that night? Maybe you're somewhere here. Were you in Taipei? Yes, this is Taipei. So this is a nice shot, of course, with all the lights. It's showing another characteristic of urban ecosystems, right? The lights. So urban ecosystem actually altered natural diurnal nocturnal cycles a little bit because our reliance on artificial lights. Right? But it's pretty. Anyway, the reason I'm showing this is because I want to use Taipei, the city you are familiar with, to walk through the history of urban evolution, urban ecosystem evolution. Everybody know this right here. Taipei was originally a lake. 8,000 years ago. Okay? It's just a big lake. And it's a basin, river basin. So it's a depression relative to all the nearby hills and mountains. Taipei is relatively low in elevation. And it's heavily influenced by two things. One is 山脚 fault, 三角断层. The other is 大屯 volcano groups. So Taipei actually is sitting in this kind of geological background and environment, topographic environment. Keep this in mind. In 1957, this is an old map of Taipei. Danshui River. Do you know what this is? Yes, Jilong River, okay? So all the orange areas, the darker orange areas are the built-up area at the time. So we still have some farmlands, and some are just, what do you call that? It's just riverbed, because you can tell how winding Jilong River is. It's not like a really straight waterway. It's winding through different fields. So all these are all waterbed, part of the river systems. So nobody lived there, no built-up areas. In 2023, satellite images. Okay, so this is Taipei again, a similar area from the old photos you see here, right? Similar area. Hey, yes, what do you notice? What's this? This is Keelung River, right? But then these are superimposed on it because we no longer have this winding, twisting and turn of the Keelung River. Now the water flows through the red area. So now this is the current Keelung River. Also these sections. It's no longer going through this. It's going through like to the left. So this is the old river. This is the new river. So what happened? As Taipei evolved, as an ecosystem, right? As we evolve, what happened? The most dominant species in Taipei, i.e. human, us, what we did as we evolve with our ecosystems.
Change the way, change the flows of the river.
Right, we change habitat structures, right?
Yeah, habitat structure.
Why? Why are we doing this?
Because of the flood?
Mm-hmm.
Yeah.
Because of the flood. Because the flood will kill people.
Yeah.
Right? So in order to have a better habitat for us, we use our technology, we build infrastructure to change the original river course into the way that is beneficial, at least we thought are beneficial to us. And this is not uncommon. Taipei is not unique. Look, how many cities around the world are developed around river, close to river, along coastal line? New York, yeah, New York, Shanghai, all the mega cities. Venice in Italy, Venice, right? So it's not unique to Taipei. One thing about many urban ecosystems is human manipulate the freshwater, the river ecosystems to feeding our needs. We do this a lot. It's being repeated all around the world. And that's why we know we tend to identify our urban image earlier when you see the photos by how channeled, how stray the waterway is. And you immediately you know this is an urban ecosystem because the waterway has been manipulated. Now this is something, it's just a nice little video clips. You can go, I'm not going to play it, but if you are interested in the history of Taipei's Keelung River, I think it's pretty well done. Of course, it's a little bit political, but anyway. So in the 80s, in the 70s and 90s, 70s, 80s, and 90s, 1970s, 80s, and 90s, we did a series of those river strengthening projects. So by section by section, we changed the natural course of Keelung rivers. Of course, government's reason is because of flood control. We want to make sure, they don't they don't cause human lives. But some people believe, at least part of the motivation behind this is to create new lands for buildings, developments, real estate. So people can build houses and sell it and make money. So that's another potential aspect of why we're doing this. So maybe part of it is because we do want to save human life. Another part is because there are some political motivations behind those projects. But regardless, we fundamentally change Keelung River, the hydrology of it, along with all the biodiversity, of course. Do you think this project solved the flooding issues? Do you recall any news about flooding? Or it did a good job. There's no longer, you can't remember hearing flooding news. It's supposed to solve the issues with 大直连内湖's flooding issues. Did it? Yes? Now think about river. River provide an ecosystem service called flood control, right? Remember we talked about ecosystem service. Flood control is an ecosystem service provided by all wetlands, including rivers. A more winding river versus a more straight river, which one can provide better flood control? Think about it. From a scientist's perspective, what you know about river, about when you have heavy rain and typhoons, in a very short period of time, you got lots of waters going into the channel. Which type of waterway will do a better job controlling those large water input, rapid and large? Which one? Yeah, why? Right, why? Yes, the energy will be reduced. And then they are overall more volumes to hold waters, right? So think about the logic. When they claim they're doing the flood control thing, what's really helping? But we do know that flooding events are reducing. That's true after this project, the straightening project. But don't forget, when we are doing those straightening, people, we engineer, tend to build dam really high and tend to build stations to draw water out. All those are part of the straightening project. 抽水站，还有堤防, right? So maybe it is those infrastructure that are helping with the flooding, not the straightening itself. So I think we are starting to learn from mistakes. So nowadays, if you have some younger engineers, they will have more ecological knowledge. So they will come up with different design plan. They know we need to use the characteristics of natural ecosystems to help us manage the urban ecosystem. So they will tend to take advantage of the original feature, the natural features, to help us manage the system. And hopefully we can reach a win-win solutions, right? Not changing the natural feature too much, but then we can also save human lives and keep allowing more people to move in the urban areas. Now, if you recall from these old maps, in early days, majority of the people congregate along Danshui River because there are many docking areas and seaport, so you can exchange goods. So of course, people will congregate along big rivers. But then as more and more people moving in, actually, I think I have a number. I just looked it up this morning. 1960s. Guess population size of the greater Taipei metro area. Taipei, New Taipei City, and Keelung. Population size. Let me give you a unit, million. What number would you put it there? 3? 1970s, just 10 years later. And then today, 2024. Anybody know about today? Oh, it's easy to look up. Huh? But that's the population size of entire Taiwan. Million. Okay. Are you looking it up? Million. Not just Taipei City.
The Great Taipei.
The greater Taipei metro area, including Taipei City, New Taipei City, and Keelung. Right, it's not just 2 million. Oh no, how much? You see the number? It should be easy to find. For 8, 9, Okay, and historically, yeah, scary, right? So anyway, so when you have 1 million people here, fine. When you have 2 million, you start to get a little bit crowded. You can build up maybe higher buildings, but when you have 9 million, you need to go somewhere because you cannot pack everybody here. So you need to colonize new land. And typically, urban ecosystems start with flat areas because that's easier for people to live in those topology, right? And then gradually, when your urban population size increases, you will move towards hills, right? Move up. You will move towards closer to the river. You will start to encroach on the riverbed. So we need those land because we're under such a pressure of urban population increase. That's why I'm not trying to be too judgmental about whatever motivation behind this. Okay, it's actually something that we cannot change. Now, before we leave this topic, we're going to move on to another topic. I want to leave you with a little story that is really relevant to us. Hey, recognize this? Look familiar. Where are we? This morning you walked in here. This is our building. Yeah. And after lunch, you will probably go somewhere here to your lab. Right? So this is an area photograph. I think this is 2023, okay? And this is 1972, the same area photograph. What was it before? Our campus, Gongguan campus, where our department located. Oh, by the way, back then, our department was not called Life Sciences. In 1955, our department was called Department of Natural History. Later, we changed it to Department of Biology and then to Life Science today. Anyway, our campus here and our department here, right? So in 1972, this area was farmland, yes. So we are part of this urban expansion. Our campus is part of this urban expansion. Other than all the buildings, the track field, the buildings, the dormitories, the little gardens, park that you saw, what else did you see as an area developed from agriculture ecosystem to urban ecosystem? What other infrastructure you see very clearly?
The roads.
Yes, highways. Linear features. Highways here. Back then we don't have all these highways are new. We only have this one road, 罗斯福路. Back then we already had it. All right, so this is another nice little piece of Taipei that can help you to get a feel of how closely an urban ecosystem is tied to its original environment. So in order to know how to manage your urban ecosystems, it's important to know the underlying abiotic and biotic environment. What was it before? All right, cool. Now I think it's a good time to take a break.